Hello, everyone. This is Shalin. We're going to be doing question 103, and the question reads: the rate at which people enter an auditorium for a rock concert is modeled by the function r given by. We're given a function, and so on and so forth. And the first question asks how many people are in the auditorium when the concert begins. Now, right off the bat, a few things we want to underline before we start. Question A is the function that's given to us, the interval that's given to us, and what the rate is what the rate is measuring, which is people per hour. This is very important. And just a few things, in the background that, no one's in the auditorium at time 0, and then the doors close at time equals 2. So in between time 0 and time 2, people are entering the auditorium. So the first question asks us how many people are in the auditorium when the concert begins. So, you know, um, for that, we want to look to this, which tells us people per hour, and we want to get people. So we're going to have to integrate as we've been doing. So to get the amount of people, we're going to take the integral from 0 to 2, because we want to know when the concert begins, and the concert begins at time equals 2. So from 0 to 2, that's when people are entering the auditorium. So you want to take the definite integral from 0 to 2 of r of t dt. And the r of t is represented by 1,380 t squared minus 675 t cubed. And this is the rate measures people per hour. So we have people per hour over here, and we have hour since dt is time. And then once we cancel, we're going to get people over here. So once you integrate this and you use r of t, which is, as I said before, 1380 t squared minus 675 t cubed, once you integrate that from 0 to 2, you should get, after using the calculator, after doing math 9 and, plugging in everything, you should get approximately 980 people. Okay, now the next thing we want to do is is B. So the next question we're going to do is obviously letter B. B, and the B reads, find the time when the rate at which people enter the auditorium is a maximum. Justify your answer. So here we're given a rate, people per hour, and we want to maximize the rate at which people enter the auditorium. So obviously you're going to take the derivative of this function and then set it equal to 0. So the original function is r of t equals 1380 t squared minus 675 t cubed. And you're going to take the derivative to maximize this rate. So the derivative would be 2,760 t minus 2,025 t squared. And you're gonna take out a t, 2,760 minus 2,025 t, and you know that t equals 0. And once you evaluate this, you're gonna get t equals 1.363. So once you get, those are your two possible points at which you have a maximum. So then you need to take out the good old number line, guys. We've been doing this all year, so this is something that should click with you, and you're taking the number line of r prime of t. So you have, 0, 1.363, and 2, right? And then once you have to evaluate this, which is T2760 minus 2025 T. So when you plug in a number before 0, so let's say -1, you're going to get a negative, and then you're going to get 2025 times -1 is a negative. So then you're going to add that. So it's going to be negative times positive equals negative. So this is negative, you're going down. And from 0 to 1.3, we can do 1. So 1, that'd be positive, and then that'd be positive as well. So we get a positive, and then we're going to go, so we got positive here, going up. Sorry about that. And you're going to, then you're going to go from 1.363 to 2. So let's just say uh, 1.5. Let's just say that for, example's sake. So 1.5, you'll have a positive times uh, 2025 times 1.5, subtract that from 2760, and you should get a negative number. So positive times negative equals negative. So you're going to be going down, and that's your behavior right there. And then you're going to see that your max is at 1.363 time 1.363. 2 cannot be a max because the the behavior of the graph, it's going down. It's on its way down, so it can't be a maximum. And the only place where we found that it's going upwards is f prime of 0 is going is is going from positive to negative. And that's what tells us that that's our maximum. Uh, yeah, so just to recap, what we did was we got the number line, and we tested out all the possible points that we got after taking the derivative and setting it equal to 0, and we got 1.363. We found that that's where our max was, since um, the slope is going from positive to negative, positive to negative. Um, yeah, so let's move on to C. So C is asking us, you know, find the total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. Function W models the total wait time for all the people who enter the auditorium before time t. The derivative of W is given by this. So this is very important for us. Keep that in mind. And we need to find this W of 2 minus W of 1, which is the total wait time for those who enter the auditorium after time 1. So what we're trying to do here is find the total wait time. That's what we're trying to find. That's what we have to remember. So since we want to find the total wait time, they tell us that W, the function W models the function W models the total wait time for all the people. So we kind of have to work backwards here because it gives us W prime of t. So W prime of t is modeled by 2 minus t r of t. And we want to find W of 2 minus W of 1. So what you're going to do here is take the integral from 1 to 2 of W prime of t, W prime of t, oh god, W prime of t, r dt, and evaluate that. So this is what you're going to put into your calculator. But you have to know that W prime of t, as the question states, is 2 minus t times r of t. And guys, don't forget that r of t is given to us in the problem over there. So, you want to plug this into your calculator, but don't forget that you have 2 minus t and then r of t, which is another equation. So after we evaluate that, we should get 387.5 hours, which is the total wait time. And to that. So moving on to D now. Moving on to D, the question asks, on average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open and use the model for total wait time from part C. So, one thing you guys need to understand, it says on average, and how long it wants to know how long each person waits for the concert to begin. So if you guys refer back to A, we found out that 980 people are in the auditorium when the concert begins. So since you're finding an average, it's 1 over b minus a, and then you're going to take the integral from 0 to x of your function. So in this case, it'll be w prime t dt. So what you want to do here is, that there are 980 people. So that's how much there were at the beginning, and obviously there was 0 before the auditorium opened. So it would be 1 over 980, taking the definite integral from 0 to 2, because that's when the people filed in. That's when they had to wait before the show started, because the show started after 2, um, of 2 minus t rt dt, which is represented by that, because we found that over there. And then once you evaluate this, you got to put this into your calculator, and you should get 0.775 hours. This number tells us how many hours each person waited. So just to recap really quickly, we wanted to find on average how long each person waits before the concert begins. And we know that from time 0 to time 2, that was when people were filing into the auditorium, and then after time 2 was when the concert began. So that's, that your interval is from 0 to 2, and you know that it should be 1 over 980, because that's how many people entered the auditorium when the concert began. So that's how many total people entered. So those are the amount of people that have had to wait to get into the concert. And then we know that w prime of t is the function that tells us, w is a function that tells us the total wait time. But when we integrate w prime of t, you have to remember that we get w of t. When integrated, we get w of t, which is the total time waited. And then once we divide the total time waited by 980, that's how many people we have, we get 0.775. So in another sense, you can look at it being from C, 387.5 hours total divided by 980 people. And you should get that. Well, this is a question. If you guys have any other... guys, scratch what I just said. The last thing, 387.5 divided by 980. I forgot that 387.5 was the total wait time from 1 to 2. So scratch that. But just to quickly recap, we have 980 people. That's the amount of people that entered from 0 to 2. And we want to see how much time they waited on average per person. And you have to integrate w prime of t, which gives us w of t, and that is the total time waited. And once you evaluate this, you will get 0.775 hours per person. That's how much time each person waited. Thank you.